morning, Doctor. We are from Team 2. Our team members are Clara, Wen Jian, Jing Yee, and also me, Tsai Jia Yuh. In this video, we will present about our question, which is question 8 for the team assignment 1.
So this is our title, where acetic acid is extracted from water into hexanol in a liquid-liquid extraction vessel. After that, the extract is subsequently separated by distillation. Assume that water is completely insoluble in hexanol. A mixture of 18 weight % of acetic acid and the balanced water is fed to the liquid-liquid extraction vessel. Pure hexanol is fed into the vessel to extract the acetic acid. The water-rich stream leaving the vessel is 99.5% of water and the balanced acetic acid. The hexanol-rich extract from the vessel is fed to a distillation column. The composition of the distillate is 4% hexanol and the balanced acetic acid. There are 4 questions. First, draw the process flowchart completely. Next, what are the basics for this process and what are the significance of these basics? Give 2 reasons. Next, if the bottom stream contains 97.2% of hexanol and recover 95% of hexanol fed to the liquid-liquid extraction vessel, determine the percentage of acetic acid in the process fed that is recovered in the distillate stream. Last, determine the mass fraction of each component in the hexanol-rich extract stream. So from the data given, we can see that there are 2 unique processes which are liquid-liquid extractor and distillation. The basis of the process are 100 kg of feed from the stream S1 into liquid-liquid extraction. So from the liquid-liquid extractor, there are 2 input stream and 2 output stream. The first input stream of liquid-liquid extractor is 100 kg of amount and the composition of 0.18 kg of acetic acid and 0.82 kg of water. The another input stream of liquid-liquid extractor is the unknown amount of hexanol. The output stream S3 from the liquid-liquid extractor has the unknown amount and 2 kg, the composition of 0.005 acetic acid and 0.995 kg of water. The another output stream of liquid-liquid extractor is go through the distillation, which that stream has the unknown amount and 3 kg and the unknown compositions, which are S1 kg of hexanol and 1 minus S1 kg of acetic acid. The another unit process has 1 input and 2 output. The input stream of distillation is from the output of liquid-liquid extractor, while the bottom stream of the distillation has the unknown amount and 5 kg and the unknown composition, which are S2 kg of hexanol and 1 minus S2 kg of acetic acid, while the upper stream of the distillation has the unknown amount of M4 kg and the compositions of 0.04 kg of hexanol and 0.96 kg of acetic acid. There are 3 boundaries from this process, which are A, B, and C. The A is for the overall system, B and C is for the liquid-liquid extractor and also the distillation respectively. So the legend is labeled here, where A is acetic acid, W is water, and H is hexanol.
So the next question is about write a basis for this process and what are the significance and reasons to use it. So the first one, we choose 100 kg is used as a basis for the feed streams S1 because it contains both the compositions of the acetic acid A and the water W, and hence it is easy to compare in finding the unknowns N2 as only water is extracted out in the streams when we use the boundary B. And next, why we use using 100 kg as basis is allow us to easy comparisons on different systems and process. It will be more convenient when we dealing with the scaling up or scaling down when the functions required, be to calculating percentage or substance in the system.
So the next question is question C. If the bottom stream contains 97.2 weight % of hexanol and recovers 95% of the hexanol fed to the liquid-liquid extraction vessel, determine the percentage of acetic acid in the process feed that is recovered in the distillate stream. So in this question, we are going to use boundary A, which is the overall system. So in the overall system, there's 4 unknowns, M1, M2, M4, and M5. And from that unknowns, we can know the DOF analysis. So in the DOF analysis, we state that there's 4 unknowns, M1, M2, M4, and M5. And also there are 4 equations. So 3 of those equations are mass balance calculations, which contains A, W, and H. A is the acetic acid, W is water, and H is the hexanol. So from that, we know that the DOF analysis is equal to 0, so that means we can solve all the equations. And so the next one is the process specification equation. 0.972 M5 is equal to 0.95 M1. M5 is equal to 0.977 M1. And that is the first equation that we're going to use later. Next one is W balance. 0.82 times 100 is equal to 0.995 M2. M2 is equal to 82.412 kilograms. So next is the H balance. M1 is equal to 0.04 M4 plus 0.972 M5. So we substitute the previous equation that we know, which is equation number 1. We substitute it to form this equation number 2, which is M4 is equal to 1.2589 M1. And the next one is the A balance. 0.18 times 100 is equal to 0.005 times 82.412 plus 0.96 M4 plus 0.028 M5. So the first and the second equation that we made, we substituted into this equation. So we're going to have 18 is equal to 0.41206 plus 1.2085 M1 plus 0.027356 M1. So we get M1. M1 is equal to 14.2314 kilograms of H, or hexanol. And since we have to find M4 too, we substitute the second equation. We substitute M1 into the second equation, so we get M4, which is equal to 17.916 kilograms. So since we know all the things that we need to know, we can finally solve for the percentage of A that is recovered. So 0.96 times 17.916, which is the M4, per 18, which is the amount fed into the overall system, is equal to 95.55%.
Next, I'll be presenting the solution for the last question, which is determine the mass fractions of each component in the hexanol-rich extract stream. For this question, we choose boundary C as stream 4 is the hexanol-rich extract stream mentioned in the question. For the DOF analysis of this boundary, there are only 2 unknowns which are M3 and X1, and there are only 2 mass balance equations which are H and A. So from the analysis, we can see that the unknowns can be solved as the DOF analysis equals to 0. So to solve for M3, we use that the total balance were in equals to out, and we get that M3 is equals to 31.82 kg. To solve for the mass fractions, we use H balance, where X1 is equals to 0.447 kg hexanol per kilogram, and the 1 minus X1 is 0.553 kg acetic acid per kilogram. And that will be all from us. Thank you, Doctor.